Hello, everyone. I'm Laura Cuss, so I look after the ATI's market and supply chain strategy. Want to say congratulations on choosing the best breakout today, and thank you for coming. I'm going to start with a stat. Would have been more dramatic if one of my colleagues, mentioning no names, Noreen, hadn't stole it from me yesterday. But the UK is 22nd in the world, behind Slovenia, Slovakia, and Germany is more than 3 times better than us. What is it? Not football, not Eurovision, we're worse at that. The UK is 22nd in the world for the uptake of robotics in manufacturing. 22nd in the world. So we're behind our EU counterparts, and we find that 5 countries account for nearly 3/4 of all global installations. So those 5 countries are China, Japan, the US, South Korea, and Germany. So why? So a survey by the engineer has looked into it, and the 2 major reasons cited are unwillingness to invest, and that's not just in the robots themselves, but that's in the skills and capability and upskilling of the workforce that need to operate and program those robots and machinery. So it is expected that the cost of robots are going to drop by 65% between 2015 and 2025, so we could see a tipping point. We could see a point where it becomes more cost-effective over that decade to, put in the robots than there is for sort of the hiring and training of people. Another fact, so UK productivity has stalled since 2008. So since the downturn. So aerospace is doing slightly better. Well, let's start. Manufacturing as a sector is doing slightly better, and aerospace is doing slightly better than that. But generally, that is where we are from the UK economy as a whole. So we do need to get better, and we are lagging behind, so we do need to get better at adopting automation. We have to look at new manufacturing capabilities. So despite where we are, PwC estimate that UK GDP could increase by 10.3% for adopting automation benefits. We heard yesterday about the importance of competitiveness. So, I think this is one clear area where to increase our competitiveness, automation can play a part. We have to get better with the productivity targets, so therefore change is critical. So what is advanced digital? So 4th industrial revolution. And it's about the right information in the right place at the right time. Our ultimate aim is to augment human value add and increase productivity. How do we do that? So we're looking to do it through removing repetitive tasks, which is where artificial intelligence comes in, easier access to information, perhaps a role for augmented reality, and improving and reducing the cost of training, perhaps a role for virtual reality. So there was a lot of things that you could choose to, sort of go along this wheel. So I've selected some of the key ones. So robots, cobots, sensor technology. Digital twin, we heard a lot this morning from quite a number of the plenary speakers on digital twin and the industrial Internet of Things. We need to look at using sort of, these technologies to get rapid new product introduction, using those digital technologies to compress the innovation cycle timescale. Autonomous and connected machines and factories. Then looking at the virtual design and certification cycle, so how can we take time out of that? And additive manufacture, Katie spoke about that during the plenary session as well. what kind of underpins all of those things as a theme? Then I think, data and analytics underpins everything, and artificial intelligence can be used in most of those applications. So why go digital? Ian Gray alluded to it sort of in his summary yesterday. So much time is wasted in processing data. 30 to 40% of engineering time in innovation process is managing data. Spreadsheets everywhere, was mentioned earlier, but that's essentially what it is. So using digital, we can take out 30 to 40% of time, and actually, what that would do for compressing the timescales. I won't read all the points, you can read them there, but, helping to avoid costly errors, missing and misinterpreting data. The jobs is the interesting one, so not necessarily fewer jobs, but better quality jobs. So a survey in 2018 asked people, would they encourage their children to go into manufacturing? Only 19% would, citing reasons of low pay and manual production line work. Is that view a bit dated? It probably is. But actually, as parents and things in society, we're not encouraging people into the industry for some of those reasons. So rather than reducing the jobs, automation will create. So moving from shop floor to maintaining programming and computer-aided design. And the reducing cost. So there's an argument that you only really increase productivity if you can reduce your inventory, reduce your cost, or increase your volume. Well, we know there's a rate challenge, so we know we need to increase the volumes. So therefore, we should be able to meet the challenge of reducing cost. Boeing developed the 777 and the 787 airframes using all virtual design. And the figures they quote is that this cut time to market by more than 50%. So common pitfalls. So we need a strategy and a plan, but we don't have to aim for perfection. Automation won't solve a poor process. You still need good processes. It will improve what you have and make it, with the benefits on the previous slide. Pilots. So again, a couple of statistics, Capgemini. So digital twin, 45% people are stuck at pilot stage, only 16% have got to advanced stage. Innovation transformation, 21% are at advanced stage, 33% are stuck at pilot. So the one other thing to bring out there as well is that, you need to satisfy a business case. It's critical, that you have a rationale to do it. It's not just investing for investment's sake. So the ATI strategy, I'm sure you all picked up your copy and read it sort of avidly last night. So I won't dwell on the exact wording too much, but we see that digital and innovation in manufacturing is covered under our cost-cutting enabler section. And it is vital for competitiveness. We see, that it has to be done through collaboration, and more importantly, it's cross-cutting. We think that there is a lot to be learned from looking across the sectors. So the key priorities, again, from the strategy. So developing high-value design capabilities. And just a couple of the applications there that we call out within the strategy document where we think that digital and advanced digital methods we should be supporting. Advanced material manufacturing and assembly, and the applications there. But again, within this one, there's the word competitive. And then the final cross-cutting enabler priority is the advancing of the through-life engineering technologies. And I think here, we're looking at the technology, the capability, and the business models. So some particular applications here: predictive maintenance, the use of drones, that was mentioned earlier today, and sort of augmented reality support. And I think, we have also mentioned in a number of sessions, but the accelerator, so the ATI supporting the accelerator, which has been targeted on Industry 4. And, I think we've been overwhelmed by the number of applications from startups, but, the amount of startups and interest that there is in sort of developing the digital capability has just been sort of shown through the applications that we've had to that programme. So that's all I was going to say. I'll introduce my panellists, but I think you all know the drill as well by now. We're using Slido for questions, 4167 to join, and you're looking for the Vox 2 on the drop-down, which says for Advanced Digital. So our panel. So we've got Simone from the Digital Catapult. She'll be telling us a little bit more about the perspective of AI from the Digital Catapult and what we can learn from other sectors. Then we've got Paul from GKN, who'll give us some insight on sort of where digital ambition is important. And then Professor Duncan McFarlane from what digital manufacturing means from many different lenses for industry. So I will hand you over now to Simone.
Come on. Yeah, okay. Hi, good afternoon, everyone. As the slide and picture says, I am Simone Webb. I work at the Digital Catapult, where I am the AI and machine learning commercial product lead. I'm not sure if everyone in the room, or show of hands, who knows about any of the Catapult or the Catapult network? Okay, mostly everyone. So I'll spare you what we do and how we get our funding. What do? I essentially work with industry to help them experiment with the various technologies. I focus on AI. I also work with our collaborative research and development team to help put together consortia for AI applications for some of the big funds like Horizon 2020. We're doing a few cool things around AI Edge and the ethical implications of that. But primarily, I spend most of my time working with SMEs and industrialists in the manufacturing and the creative sector. So today I'll just chat through really quickly what we've seen on the ground. So from an AI perspective, I've been at the Catapult 5 months. Before then I was doing machine learning at Accenture. And what we find is that when companies come to us and they want to experiment, they have a preconceived notion that AI is the solution to their problem. And once you start unpicking about what their drivers are and what problems they're really trying to solve, whether it be engineering and design or manufacturing or aftermarket, AI 95% of the time isn't a good enabler or solution. A few companies have come and they wanted to do machine vision to help QA the products that they're developing. So one example is a company called NSERC. They manufacture glass bottles. They were having defects along their production line. They wanted to use machine vision. So we go there, we sit, we chat with them, really unpack that actually this is an AI problem, not a statistics problem. Then we realize they don't have any data. So one of the things that companies do come to us, they want to be efficient, they want to optimize their operations, but the challenges we face is that they don't have any data or they don't really understand how AI can solve their problem. Companies also come to us and they would like to look at how they could upskill their staff. So teach and evangelize AI and advanced technologies within their organizations and their entities. So we help them with that as well. And they come to us because they want to fail fast, right? You can go to some of the big players and invest millions of dollars to determine if one of the solutions could potentially be a right fit to integrate into their digital transformation. We offer a space where they can experiment on a small scale, depending on the outcome, pivot either left or right, and then do another iteration. We find that that's a good business model for them. Most of the cases that we've been seeing is either in machine vision from a quality control perspective or in a predictive maintenance case. So I know I chatted about the challenges really briefly. So the first one is really about what AI can and can't do and the quality of the importance of good quality data. So we run some academies around that just to educate SMEs because again, they come with a preconceived notion that AI is what's going to solve their problem. And we really have to take them along that journey about what it can't and can't do for them, as well as data. We are able to train models on open data occasionally, but most of the times we need real world input and outcome data from that actual company, from that process, to actually build a model that would be beneficial for a proof of concept experimentation. And finally, companies want to know, if they experiment, what is the ROI they'll potentially get on their shop floor, or what is the ROI they'll get when they do their simulations before they go to the manufacturing space. And we help them frame that as they go through the proof of concept cycle so that they can go back to their CFO and actually be able to quantify, at least at a medium level, what the value is to their company and their operations. Thank you.
Okay, thank you, Simone. So next, to introduce Paul Clarke.
Hi, I'm the other Paul Clarke. So I've come here to talk to you about, I don't know if many of you know me, but I helped to develop the digital paper for ATI before, and working back in GKN, it's fantastic to sort of talk a lot about the opportunities and listening to the entire community of what they saw their priorities were, and then actually looking at the adoption of digital technologies. It's really hard. And I just wanted to take you through some of that and how we actually, what we're doing at GKN and how we're looking to support both our supply chain and our partners, but also to move us forward in a progressive and mature way. So the first question you ask with digital technologies is, why are you doing it? And the reality is that you need to, because your customers are asking you to. We're in a process at the moment with our customers where the expectation from a commercial perspective is that we are driving a different way of working. We're looking at the data that sits within our factory so that our customers can adopt their own digital practices and that they can deliver that. The SMEs make up 99% of the overall UK manufacturing footprint, and there's a fifth that are less than a fifth that are highly digitized. In aerospace, I would probably say that's less. And the challenge that we have within aerospace is that we have products that last quite a significant amount of time in terms of manufacturing. You qualify them very early in the process, and it's very difficult to make changes to what you're already manufacturing. So the adoption needs to start on every new program that you're putting forward now, and how you can then use some of that going forward. And I'll give you some examples of what we're doing in a second. And also, this is a global market, and there are different incentives that span the world, in terms of where you work in Singapore or you work in the US. There are different initiatives driving a different digital agenda where you get different opportunities for funding. So you need to be competitive, otherwise those productivity gains that are being made, you really need to start to push those forward. So how do we do that? So we've talked a lot about proof of concepts. You look at co-creation. We've had in GKN over 200 digital programs, different proof of concepts working and pilots working. And exactly as Laura said, how do you actually move that forward? Referring back to Paul Clarke's other presentation, working in different industries, handling different products, you can be more disruptive in certain areas. What we found is that, and what we've gone back to more recently, is making sure our processes are robust. The processes that we already generate, we have good lean philosophies, we have a good continuous improvement program to make sure we understand our own processes. If we can deliver our own processes, then we can really understand how we might migrate to the vision of model-based engineering, how we can really understand the processes that are going to drive the improvements we see in design, and then how we look at APQP and the AS 9145 systems to drive that into our process capabilities going forward. One of the things I've found is you want to be able to separate out some of your day-to-day work from where you want to see your digital improvements. So within my technology group, as a good example, we've been putting digital technologies both into our products through our optical ice detection program, where we're looking at using AI as a way of filling in the gaps in the data that we can't see today. And we've been using, we've changed the role of the systems engineer that we're starting to think about in this space and move them into a data science role where we can then allow him to sort of stretch and to explore and test our own thinking of manufacturing processes. A good example, we manufacture the A320 flight deck window today, and as part of that process, it's obviously a very mature program, we evaporate gold onto the surface of the window to create an icing performance on the front of that window. To do that, you have to put the window into a vacuum, you have to evaporate the gold with a plasma, and then evaporate that onto the surface. And you want to hit a specific resistance for that gold so that you can perform everything you need to do. It's an art form. It's an awesome product, but it's an art form. So what we've started to look at is looking at building bricks to develop that product into a way where we can use digital, we can use data to improve our processes. And one of the ways we do that is we collect the data. We start to understand, we're starting to put sensors into that vacuum chamber so we can understand the point at which we hit the evaporation, where those individual pieces of gold are to deliver that. And then we started to look at the pulling that data out, that data acquisition, looking at how we can transfer that into a system that we can then utilize. So looking at the data acquisition, the data collection, and then the visualization. What are we actually seeing from that data set? And then can we start to make manual alterations to that process? What we want to do is close the loop, put the analytics in to say, this is where you're seeing some discontinuities, and then being able to modify that in real time to improve that product performance. And we're starting to see real benefits from that. So as I mentioned, I think it's about applying lean. It's about making sure you understand your processes, making sure you understand the boundaries of what you can achieve, and then deploying digital tools and digital assets on top of that where you can see real business case, real value for doing so. Another great story that we have in GKN is we're developing a new global technology a new global technology centre in Bristol in Filton, and whilst we're developing the lean opportunities in our operations cells, we're using the GTC as a real sandpit to develop new capability, to explore a different way of developing digital technologies, using that as a collaborative space, bringing in our partners, bringing in different ecosystem to really test the boundaries of digital technologies in there. So within, I don't know if you can read that, within using it as a way to drive digital innovation, one of the things we focus very much on in aerospace is our operational capabilities. We need to change our mindset. We need to look at how we adopt this and setting up specific digital teams to really challenge our sort of day-to-day. We also need inspiration, both leadership from the top down, the opportunity to go and test these demonstrations, and also bottom up, having interest in new technologies and new ways of doing things, because we've got capabilities in the team to do this. We've got some very smart people in our business. And what we've done within GKN is we've developed a CTO challenge. So this is a challenge looking at a new urban air vehicle for rescue, for single-person rescue. And we developed 6 different concepts. There was about 200 people, I think I'm right, Paul, about 200 people doing this in their own time, developing new ideas to go and challenge the status quo. What we learned from that is we learned that there's capabilities that exist in our business we really didn't know were there. Systems capabilities, testing, the amount of model-based engineering that we did with that, building demonstrators, looking at additive manufacturing. It really helped to push the boundaries. And we want to take this further forward and utilize those skills so that we can do something different, something that we don't do in our manufacturing today. And finally, this is my last slide, what can you do? So there are multiple mechanisms for being able to do this. And we've talked about it a lot. The ATI Accelerator I've been very fortunate to work with Boeing to do the assessments of the different companies that have been involved in putting forward for the Digital Accelerator. And there's some amazing companies in there, really testing what aerospace can do and what they think they can provide and what they can bring to aerospace. So I definitely see if you can get involved, go and talk to the ATI about how you can deliver that. NATEP is another, that's the next evolution on. Are there companies in here that we can bring into NATEP? Are there other startup companies through universities, through the research organisations that we can start to bring in? And Made Smarter. Made Smarter is a fantastic initiative to really drive the foundation of digital manufacturing in the UK, and it covers a multitude of sectors. So we're working with GSK, AstraZeneca, Rolls-Royce. There's a whole range of different companies that we're working with. And then ATI is, we're here to talk about digital. There are some fantastic opportunities, and there's some fantastic digital projects that already exist within the ATI. So, I think as GKN, we're ready to collaborate if people are interested in working with us as well.
Whatever your choice is, Duncan. So, yeah, thank you, Paul. And now just to introduce Duncan McFarlane.
You've got the button. Yeah. Thanks, Laura. Okay, so only one academic on the panel, so I have to put a whole lot of writing on my slides. In fact, this one was looking so boring the other day that I chucked a couple of pictures of Cambridge on the side, so they don't really have much to do with the talk. But I was in the back of a lecture trying to get this together. I'm Professor of Industrial Information Engineering in Cambridge, and broadly within the Institute for Manufacturing I cover the digital manufacturing program, which actually ranges from technologists to policy type people. So it's quite a broad activity, involved in a couple of a number of industrial things, including the Boeing Cambridge program and a company called Redbyte. And then jointly with Svetlana Ratchev, who's sitting in the third row here, we're an investigator on something called the Digital Manufacturing on a Shoestring program, which is looking at very low-cost digital solutions for SMEs. So I just want to provide my perspective from actually talking to large and small companies about the digital developments we've been seeing in the last couple of years. Firstly, I think actually being the third speaker, you end up saying what everyone else has already said, and I think Paul and Simone both said, there's no need for any digital solution at all unless there's a business rationale. I think that point's been made. Perhaps an interesting point that's not been made that often in terms of the operational needs for digital is pretty much everything I see when people start talking about digital manufacturing today, as opposed to digital solutions 10 years ago, is predominantly opportunities that are non-core to production. So they're either in the periphery of the production environment, or actually in the supply chain, or in the flow of materials through the workplace. So we're actually sort of seeing the evolution of quite a lot of stuff that in this new wave that is rather different to what we've considered in the past. Technology-wise, this is slightly controversial, but as far as I'm concerned, there are very few new digital technologies that we're looking at, full stop. We've talked about AI. Well, first AI activity in manufacturing I'm aware of was 1985. The Internet of Things, I was involved in a project which kind of came up with the label, failed to exploit it in about 2000. And so, most of the technologies we're talking about are actually quite well developed. So when someone says there's a whole lot of new technologies available, take that with a grain of salt. What is important is the fact that we can actually do much more with the technologies that are available because of better computing and communication systems. So that's a key point. And as I said, the other thing is, we often forget that there's quite a lot of existing industrial IT in place, and has been for quite a while. So any new solutions are not there to replace a lot of that. They're to work in a complementary way with it. So just some comments on, I guess, the perspective of seeing quite a number of large and small companies and their views on what works and what doesn't. And in a way, this sounds a bit contradictory to, the comment that Laura was making about pilot studies earlier on, because I actually heard a really interesting talk from let's say a German glue manufacturer the other day about digital, and their approach has been they do lots of pilot studies, but in a very structured, systematic way, which they never set out to work out a business case in advance. They just have a gut feel it might be a good idea, because their view is the pilot study is a great way to help them generate a business case. So I've seen companies doing systematic experimentation with pilot studies. But having said that, there's a lot of work in trying to identify priority areas. And so actually, so Laura talked earlier on about those 3 dimensions, which I think they're pretty well developed now: the smart factory, the life cycle, supply chain, and the value engineering. And companies that can identify which dimensions of digital solutions are better for them are in a much better position than those that just say we're just going to embrace digital overall. And particularly, just coming back to the earlier point about the fact that there is existing industrial IT, being able to strip the paradigms, whether it's Industry 4 or industrial internet, or let's say made in China 2025, so all these paradigms that are around, stripping them back to the basics and what they actually can contribute and add benefit to in the operation is really important. So as I said earlier on, we're doing quite a bit of work with small companies, trying to look at ways of developing low-cost solutions for them. And in those discussions, these are the sort of outputs we're getting from. We've run a whole lot of workshops in the last year. But our general finding is that small manufacturers are actually super enthusiastic about digital solutions, but massively constrained, whether it's constrained in terms of the amount of money they have to spend, actually full stop, let alone just on digital solutions, and also skill-wise. And so there's kind of a need for simple and low-cost solutions. And this is the other one, which is kind of, it sounds a bit weird, but the body language of someone from a small company when they hear they've got to go on a journey to achieve their digital goals, they sort of sink like this. And I think in their mind they feel like they're kind of like Frodo setting out to take the ring to Mount Doom, and it's going to be about 3 years before they achieve anything. So small companies like to just think about, would like to just have a solution. And maybe they can have more than one solution, but a solution up front rather than a long journey to get to the end. So, just to summarise, some of the key messages that would come out of that is, what I call no wheel reinvention. This is a rather poor cartoon of, this is meant to be the existing IT infrastructure within an operation. Hang on to it. Use it, and there's a lot of low-hanging fruit by adding stuff around. So whether it's within the factory, I don't think this pointer works. I'll just do that. It's up there. So whether it's inside the box, in the factory, or in the supply chain around, there's lots of low-hanging opportunities to pick up. And secondly, for SMEs, this thing about solutions, not journeys, and we're actually looking, which is kind of an interesting opportunity for kids as well, but looking at trying to implement non-industrial technologies in an industrial context with the focus on getting very low-cost solutions out. Thank you.
Thank you, Duncan. So again, just a reminder, using Slido for the questions, so log on, ask the questions if you haven't. You can also vote for your favourites, so they'll appear closer to the top, more chance of them being asked. Okay. So first question then, which we have at the top. What new skills does the sector need to embrace digital? Are schools and universities sufficiently primed to meet these changing needs? I guess I'll point down at you, Duncan, initially.
I'll try not to answer the question. I'm sure we will do that. But some comments on skills is, I think make three points. Maybe the first one is, there's a whole lot of new digital skills that our kids are acquiring, whether we like it or not. And it would be great if we could actually work out how to exploit them within the industrial domain. Secondly, are universities helping students to acquire the right skills? I suspect probably not. And I know we're looking very hard at the way we will teach students in the 21st century because we're predominantly giving them capabilities, but not digital skills particularly. In fact, I think I'm learning more from my students than they're learning from me in that area. So that's not good enough at this stage. And the other interesting thing is, I feel like there's maybe an evolution in digital skills taking place. And I saw someone talking about the evolution of NC coding the other day, and I don't know if I can remember the whole thing, but it's something like we've gone from punch cards to programming, and where we want to go to is coding, conversation. And I think what was interesting about that is there are some developments which is about taking technologies to a point where you don't have to be a supersonic expert to program an NC machine. You can actually talk to the machine, and the machine can unravel what you're saying and turn it into a systematic piece of operation via coding. And so I think that's an interesting thing for where we have people that are already in the workforce that don't have digital skills. We keep saying we've got to take those people to develop their digital skills, but why don't the digital systems providers take the digital systems to people's existing skill area? So that'd be a slightly radical question. Is the job of the people to reskill themselves, or can the systems skill themselves better for those people?
Yeah, no, that's interesting. Paul, Simone, anything to add?
So I would say that there are some fantastic apprenticeship schemes now that are looking at developing the skills in young people, but also any demographic. And I think we should be looking at not just students. I agree with Duncan. I think I look at my kids and the capabilities they have in terms of programming already, and they're 10. So it's phenomenal. But places like the MTC, there's a fantastic scheme where students are learning both, the ways in which they could operate in the factory today, but then bringing in skills that are developing that digital element around the same area, so that they can help the adoption of those technologies into a factory. I think there's a gap as well potentially in the ability to articulate the business case. What is the need from a business perspective to adopt this, and how can students bring that to industry? Because I think that there's a minefield of digital opportunities out there, and there needs to be, I think, a national infrastructure, potentially through Made Smarter, that starts to articulate the kind of basic building blocks of what that looks like and how vendors can support that.
Okay, thank you.
I think it's a bit more fundamental. So the way I see it, in 20 years, the technologies that an 8-year-old would be using would be completely obsolete today, from today's perspective. I think, up until probably 12, 13, it's all about critical thinking, exposure to science, technology, the arts, and teaching kids to think. I think if you start at that angle, you build the fundamentals wherever the technology goes, in the next 10, 15, 20 years, whatever the jobs of the futures are, they have a baseline in terms of how to navigate that.
Okay, that's a really interesting thought. The skills is obviously popular with our audience today. So countries with a high use of automation also prize manufacturing engineers as a vital skill. So I think we can see sort of where Germany is and some of the others. What can we do to develop manufacturing engineers in the UK? So some of you covered it slightly there. Is there just anything you'd expand within that question? Paul?
Yeah, I think there is a genuine need to improve manufacturing engineering today. So the challenge that I know we see, and I'm sure other aerospace companies see it, is that and we're starting to see it a lot more now, is you're developing some of those automation skills, some of those specialist skills that require a different type of thinking, a different type of approach. And there is more money to be made outside of aerospace than there is inside it. So you develop the capabilities in robotics, in AI development, and then there's a wealth of opportunity in London or anywhere where there is an opportunity to go and develop that new technology. I think about this in a slightly different way, in that anybody should be able to have access within aerospace, have access to develop that type of technology and to challenge the status quo today. So having incubation or think tanks where you can go and demonstrate and see this technology and see it working and see what it means. And there needs to be a transition, the learning from what we've done, especially in aerospace, where you've got existing products that have not really moved in terms of their manufacturing type. Continuous improvement and lean is fundamental to that, so you understand the process. But if you want to go and do something different to improve your productivity, you've got to have that kind of mindset, and we're not going to get that unless we start getting the training into people.
Okay. I'm not sure if any of the other panel want to build on that, or if I jump to the next.
No, I mean, I perhaps just add to it that, I mean, we train manufacturing engineers in the part of the course that I teach, and there's an infinite demand for them, so there's no problem. In fact, some of the challenges are keeping them in manufacturing, but I think one of the things that we're trying to look at more is how do we get students from other parts of engineering, other parts like computer science, materials, and even the humanities, more interested in manufacturing activities. And one of the ways we just ran a hackathon a couple of weekends ago, where we had 50 kids come in to do like 2-day development of 3 different low-cost industrial solutions. And actually the enthusiasm was massive. And a lot of those students, almost all of them, I think there's one manufacturing engineering student there. So I think it's how do you make manufacturing seem an interesting area for people working with digital skills to go into, as opposed to maybe a pure services area. So I think that's an interesting challenge.
Yeah, so making manufacturing synonymous with digital. So what would be suggested as a first step for a company with no digital twin or automated data collection? Simone, do you want to have a go with that one?
I think if it's an automated data collection angle, I think for sure sensors and IoT would be one of the first steps. But if I take a step back, it'll be really figuring out what your architecture is to collate and constantly feed that data. So starting from the architecture, the strategy, but also, collecting data, it's an ongoing thing. You don't know you need data until you actually need to solve a problem and need deep insight around that. So it's collecting and tagging everything, not undervaluing the value of unstructured data, building the architecture around that. And then if it's, across the shop floor, building in the sensors and IoT solutions to continue feeding that data lake.
Okay.
Can I add to that? Yeah. So I, having seen some of the digital programs in practice in GKN, we've looked at 4 main areas. So the first being data acquisition, being able to track that, find what you want to track, looking at the visualization of that data. So once you have the data, can you start to see trends? We see this as a more of a maturity model in terms of, because it's a relatively low cost step, but you want to be able to make those incremental steps. Then looking at the analytics that sits around that data, like say unstructured data, can you start to see value in some areas, gaps that you couldn't see any other way? And then predictive maintenance. One of the things that we have as a big issue in aerospace today is legacy equipment and how we can prevent the failure of that. If I wrap all of that around a structure, and one of the things that I think is essential for UK aerospace is an enterprise architecture that people can adopt, because there are multiple vendors out there that will sell you everything that connects to everything else, and it can become a very difficult task to try and mine through all of this information. So I think there is a definite need, and I think that the UK could benefit from a unified architecture where any software provider could put their software into a standard process that we could then anybody could use, and the supply chain would have a point to go and start. We have a lot of startups and a lot of pilots. We've got the Northern pilot through the Made Smarter initiative at the moment, and that's great. But the adoption will need to come from trying to apply a relative standard that people can work to, because people are reluctant to invest on the basis that they invest in something that doesn't last very long.
Okay, thanks.
Not much to add, but just that, data collection on its own doesn't give you any value. So you do, as Simone was saying, you just need to know you've got an application with a business need that would require that. So I think that would be generally all monitoring, all sensing is valueless unless you're going to know how to exploit it.
Yeah, so know your plan. So related to the other Paul Clarke's challenge this morning, I think. So how do we make national digital twin a reality? How would we break down the barriers to make it a reality? Anyone looking as a volunteer?
Paul's really good.
Well, you've got to start somewhere, and I think from a national digital twin, I think you've got to start with a baseline of something that people can adopt and use, and then that you can grow. And I think whether that be a digital twin in terms of, I was trying to understand what he meant by a full digital twin of the UK. I don't quite know. I wasn't there, so I hope you tell us. I think that it's, as I was saying before, I think we need to set a structure and a baseline that people can adopt and work to, and have a starting point that industry or academia that can lash onto and actually start to test in their own way. But if you're doing it as a collective and as a collective group that's bigger than aerospace, there's some fantastic opportunities that opportunities that Ocado are bringing to the business, to industry, that we could look at and start to see how we could adopt some of those technologies, because I don't think aerospace will necessarily lead that area. I think there are other sectors that are really pushing the boundaries. Finance as well. There's some amazing fintech companies out there that are pushing the boundaries, and programs like Horizon X are gonna find that. They're going to find those opportunities, and maybe through the accelerator program we can start to see the benefits of those startups that are going to start to revolutionise our thinking in aerospace.
And to break down the barriers, then, do we need to push for more collaboration? And is that how we overcoming the barriers?
It's what we've learned. You can't do this by yourself. You couldn't invest enough money to support it. You need to work in a collaborative space where you can look at a common approach. Common systems, or if you can't have a common system, an ability to communicate between different systems to deliver that.
Go on, Simone.
Nothing to add.
Well, given that I wasn't there, it's hard to add to that. But I'm assuming by national digital twin, he kind of means it's something like a zoomable Google map with real-time data.
You did
keep
it
up
street.
Yeah, something like that. And I guess that's a nice thing to have. But I suspect it'll be a bit like if you wanted it, it'd be a bit like a sort of a finite element array. There'll be areas where you want to be able to zoom more into than others, and other areas where you don't even want real-time data updating. I don't think the top of the Cairngorms is probably needing rapid updating, for example. So it's just a horses for courses, but you could probably say we've got a national digital twin now, because there's various mapping technologies, Street View or whatever, that do something like that. But I think it's what we want to use it for is probably the interesting question.
Yeah, very true. What's stopping companies embracing Industry 4.0 right now? Simone, have you got any perspectives on
So I find a lot of organizations, they work in silos, right? So it's getting buy-in from the topmost level. So, at the Catapult, we focus on 5G, AI, AR, VR, and companies come to us, but it's specific departments that are driving agendas, and they don't necessarily integrate with other departments within their companies. So I think from an adoption perspective, it's always buy-in at the right level. With these new technologies, it's also acquiring the skills in-house or partnering with someone like Digital Catapult to help them build that capability and help them experiment. And sometimes it's just a cultural shift. So some of the SMEs I visit in the Midlands and up north, the idea of going digital or even investing to go into digital, they don't see the value yet. So it's trying to figure out what's the balance between navigating those obstacles.
You go next.
Okay. I was just going to say, is what's stopping companies embracing it? I think I said on my slides. I mean, why should they? An alternative is to address your business needs using digital tools, and not embrace all of Industry 4. In fact, it's pretty hard to work out exactly what Industry 4 is on any given day. So it could be a company just being sensible about its policy, rather than putting their head in the sand about digital solutions.
Okay. I think we perhaps have a chance for just one final question, and we've got a name against this one, so we have someone in the audience to point at. So from Paul Pereira, with a fragmented architecture of IT, is there an opportunity for the UK to set a standard that allows the entire value chain to bring an aero digital twin linked to sustainability?
Yes.
Do you want to take that one then, Paul?
So yeah, one of the things that we've been looking at and looking to collaborate with a number of partners on is an ability to link together a fragmented digital ecosystem where we all want to look at the data acquisition. We actually want to look at it in terms of not just our ability to collect data on our shop floor, but the ability to influence our business systems, the ability to influence our maintenance, the ability to influence the way in which we design product and develop product for the future. So to do that, there's a fantastic standard called ISO 95, which is looking at the different layers. And the challenge that we have today is that within the IT framework, there are multiple vendors offering multiple solutions that cover a lot of each other's domains. So if I talk about ERP and MES, there's a lot of overlap between those different things. And I think there is an opportunity to build this system where we can, and we've been looking at this through the Made Smarter initiative, to try and really challenge the vendors to say, well, this is, you can provide your system, but we need a Siemens system talking to an ATS system, talking to whichever system, a SAP, and a seamless integration between these systems so that you can effectively look at the adoption both through the OEMs, through the tier 1, tier 2s, which is where it normally starts, but it also gives the opportunity for the supply chain to engage as well, which is the big missing part, the missing element, because you're only successful at delivering and adopting your digital technologies if you can articulate the business case, and the value proposition isn't just you buying an individual system, but in changing the way in which you adopt technologies and how your supply chain can then give you additional productivity value, because you can see more into the supply chain, you can communicate on a different level. So I think there's a genuine need I think there's a fantastic opportunity for the UK to do something fundamental and change the way in which we operate from a digital technology perspective.
Okay, grand. Anyone want to build?
Yeah, okay. So I would just agree with Paul, and I think I really like the question, because mostly we're talking about how do we just keep up with everyone globally. It'd be really nice to find a way to get ahead. For me, I've been talking to BSI a lot and trying to get them involved, because I think it would be really nice for BSI or a British standards body to take a lead on putting some integrated standards for the modern digital manufacturing space together. And that we know there's some under development elsewhere, but it'd be really nice for it to be a UK flavour to it.
Okay, thank you. So I'd just like to say thank you to my panel again, and thank you to your audience, as an audience, for your participation and your questions. So thank you very much.